Hello, everybody, and welcome. This is the Building Walkdown, Uncovering Hidden Opportunities for Savings, a webinar and a presentation by Melissa Sokolowsky of the Smart Building Center. My name is Karen Janowitz, and I'm a program manager at Washington State University Energy Program located in Olympia, Washington, where for over 10 years I've been running a support program for public sector resource conservation managers and similar such positions in Washington State and the Northwest. The program provides a monthly newsletter for RCMs, and it provides webinars and publications, support, and more. My other hat, overlapping, is working on energy efficient emerging technologies. So this webinar is being recorded and will be posted to our WCR Energy Program RCM website, as well as to the Smart Buildings Center website. And the link to those is at the end of the presentations. Before we begin, we encourage audience participation. However, all attendees are in listen-only mode. So to participate, please ask questions in your question, in that little question dialog box in your control panel. Ask questions throughout the presentations, as well if you're having difficulty hearing or have other types of technical questions. At the end of the presentation, I will be asking Melissa the questions that you have jotted down. So next slide, Melissa. This project is supported by the U.S. Department of Energy, Energy Efficiency and Renewable Energy Office, with grant funds administered by the Washington State Energy Office, Washington State Department of Commerce. So thank you very much to those agencies. So when Melissa goes to the next slide now, and I'm going to introduce her. Melissa Sokolowsky is passionate about innovative solutions for a clean energy economy. As Senior Project Manager at Northwest Energy Efficiency Council, otherwise known as NEEC, Melissa serves as Training Manager for the Building Operator Certification Program. At NEEC's Smart Building Center, she also manages the tool lending library and provides technical consulting for the region's commercial and institutional buildings industry. Melissa has logged many years in various trades, such as construction, renovation, and equipment installation and repair, and she has over a decade of experience in commercial facility operation and management, including as facilities manager of the LEED Platinum 21-acre center in Woodinville, Washington. She holds degrees in sustainable building science technology, energy management, and graphic design, and she holds, of course, a building operator certification, a LEED Green Associate certification, as well as certificates in residential auditing, commercial lighting, project management, and electronics troubleshooting. So now I'm going to turn this over to Melissa.
Karen?
Yes, you're welcome.
Thank you, Karen. I think I'm unmuted now. You can hear me now, I assume.
Correct.
And thank you. I am really happy to be here today, and I'm grateful for all of you to participate in this presentation. It's important stuff, and I appreciate everyone's enthusiasm, as well as I'm anticipating some great comments and questions at the end. So again, I am from the Northwest Energy Efficiency Council, and we are a trade organization representing the energy efficiency industry in the Pacific Northwest. Project of ours is the Smart Building Center, which is a resource for the industry. We have training rooms and all sorts of wonderful resources here at the Smart Building Center, including a tool lending library for diagnostic and monitoring tools. And I'll talk a little more about those tools later in the presentation. We also run a Building Operator Certification, or VOC, and this is the leading training and certification program for building engineers and maintenance personnel. And graduates tend to save their organizations around $12,000 to $20,000 a year. So it pays for itself many times over very quickly. So let's get started here. the next slide. Here we go. No, come on. There we are. All right, so our objectives for today are to describe the benefits of building retuning and identify some common retuning measures. And we'll describe 4 steps to the retuning approach and also list the major focus areas. And retuning has often been practiced in the context of larger buildings, typically with a building automation system. But it's very beneficial in all buildings, so today we'll consider its application in smaller, less complex buildings here in the Northwest. All right, I'm having trouble with my mouse here.
Can you use your enter button?
Yeah, I was trying to do that. It was also giving me trouble, but let's see what we can do. There we go. All right, thank you.
You're welcome.
So, definition of building retuning is a process to identify and correct operational problems and identify no and low cost methods to correct those. And this is exactly what resource conservation managers and energy managers and facilities managers should do. And so we'll cover a lot of these topics are associated with energy auditing and electrocommissioning, and many of these recommendations will be prescriptive because many small buildings, oh, excuse me, I'm sorry, sorry about that. Small buildings will generally not have as often times a building automation system, but will be using packaged units for heating, cooling, simple air distribution, controlled by a zone thermostat.
Excuse me,
look at
Melissa? Sorry, everybody. We're working out the presenter and the GoToMeeting thing. I think you need to take keyboard and keep control away from me again.
Okay.
Did you do that?
I'm trying to do that here. Oh, I see.
If you take it away from me, then you won't have that problem. There you go. Now I think.
There we go. Okay.
Yay. Perfect. Okay, everyone. Thank you for hanging in there.
Yes, thank you. So right now we're looking at this slide which shows the life cycle of building retuning over time. So you can see the top blue line here will show a typical building behavior over time. The efficiency starts to drop as energy consumption rises, and that's just due to equipment starting to age and becoming out of tune, and also scheduling issues or setbacks that get changed or set points, etc. So as you can see, the blue area shows the potential for reducing that energy consumption every time a retuning process happens. And then you can also see that after those measures happen, again, the energy consumption starts to creep up. So you can see that in the green areas, this shows the possibility for maximizing the persistence of those energy measures and savings over time with continuous retuning process. And here we have some extensive research that was done by the Pacific Northwest National Lab. And looking at this analysis was of 100 buildings, and these were small to medium-sized buildings. This just shows the common retuning measures. And as you can see here, this is dominated by strategies of temperature and pressure reset, which basically will adjust those set points based on outdoor air temperature. And this takes advantage of when the building load is at less than design conditions, because there's often some wiggle room there to save energy without actually affecting the comfort of the building. So you can see here, reset strategies dominate these measures, as well as set points, deadbands, and setbacks. So just to show what are some of the top things that we can be looking for in our building retuning process. So our major focus areas are going to be, of course, HVAC, lighting, both lighting and controls, domestic hot water, water use, and the building envelope. And the approach we recommend is a four-step approach. The first phase being data collection, and so that would be gathering utility bills and general information about the building, its construction, its envelope, etc. The investigation phase is the second phase, and that's the step that we'll be focusing on here today. And that is the actual building walk-down to identify and characterize the building operation, using more of a hands-on approach. The implementation phase is the process of applying those measures that will be recommended as a result of your analysis. And documentation is to report the measures and calculate the energy savings. And it's important that each of these phases utilize good documentation skills. The building technicians and engineers who will be completing the retuning process will really appreciate a thorough set of documents, including your observations and any other data that is collected. And I do want to emphasize that there are just a few basic energy management principles that you could keep in mind. If you don't need it, turn it off. If you don't need it at full power, turn it down. And of course, make smart energy decisions when adjusting systems while keeping in mind the safety and comfort of the occupants, as well as the efficiency of the building or the business operations. Now, I also want to note that sampling is okay. You may have a building that has many more pieces of equipment that you can individually look at in your walk down. So the rule of thumb is to observe and test at least 12% of the equipment. So if you have, you know, dozens and dozens of VIV boxes, for example, you can certainly just sample a small sample of those pieces of equipment. And during the building walk-down, the most important tool that you carry with you are your senses, of course. Look, listen, smell, and touch. Of course, be careful, safety first. But in the wise words of Yogi Berra, you can observe a lot by just watching. So another recommendation is to, if possible, perform a walk down during both occupied hours and unoccupied hours. During occupied hours, take notes not just of the things and the equipment, but also what are the occupants doing. And then night walk down is really highly recommended because energy waste often occurs during unoccupied periods and holidays. And even if you don't have the opportunity to get inside the building at night, even just doing an exterior inspection will allow you to kind of view into the building and even just getting a sense of how many lights are still on, for example, that may not need to be. You also want to walk down the building at least once during the heating season and the cooling season, because obviously equipment is going to operate differently with different scheduling and set points based on the various needs of the season. And again, logging your observations is key. So some basic tools to carry. one of the most basic tools, it's a pretty low-cost item, is the infrared temperature gun. That's going to allow you to determine temperatures on supply and return, water, for example, and we also carry these tools in our tool lending library, along with some of the other tools you see pictured here, like the light meter, which is essential for getting light measurements, and then basic tools such as a screwdriver to open panels, etc. Of course, personal protection equipment, gloves, goggles are very useful. And then another item pictured here is a little more expensive. That's our infrared camera that is super useful in all sorts of areas in your building walk down, not only for the building envelope and identifying air loss, but also for looking at pumps and motors, abnormal wear, etc. So we also have these tools, these infrared cameras available from the tool lending library. All right, let's dig into the nitty-gritty here, and we'll start with HVAC. I have another slide here from the Science Parks of the Pacific Northwest National Lab, and this just shows the most potent measures in small buildings without BAS. And you can see that those across the board tend to be scheduling and deadbands and setbacks. So that's where we'll start with scheduling. And typically, small and medium-sized buildings will lack central control, so they'll be controlled by wall-mounted thermostat that control both the heating and the cooling. So you want to observe what type of thermostats are controlling these systems. Are they mechanical? Are they digital? If they're digital, are they programmable? So replacing mechanical or even non-programmable digital thermostats can save a lot of energy if they're properly programmed. So that's a good recommendation to make if you're noting mechanical or non-programmable thermostat. Another thing to note is where the thermostat located. It ideally should be in a location that is not affected by passive heat gain, for example. And scheduling, again, equipment schedules can get out of whack. So you have a nighttime event and you override your schedule for just that event, but somebody forgets to reset the schedule. So then forevermore, until somebody notices, you have your equipment running all night or in the evening when it doesn't need to be. So here, what we can do is, even if you're doing a night walk down, you're typically not going to stay all night, so you might not know what's exactly happening all the time. That's where these little motor loggers come in handy. It's a very handy little tool. It has a magnet that will just let it simply attach onto the motor case, and these can be used for fans or pumps to verify the on-off status of the equipment. And you can see in this graph here shows the on-off status. It's pretty clearly coming on Sunday, going off at night, coming back on in a pretty regular pattern. You might note if this building has a weekend schedule or not. This is showing that it is a 7-day on schedule. Maybe it doesn't need to be on 7 days because you only have a 5-day operating schedule. So the next thing to do would be to review the set points on each method of control, each control equipment device. And so this includes, your zone temperatures, outdoor air, hot water, chiller water supply, etc. any pertinent set points should be reviewed. And you can adjust those to optimize function, use your best judgment, of course, keeping in mind the business operations and the comfort of the occupant. Now, sensor calibration, and this is important to do periodically, especially on the critical sensors. So critical sensors would be those controlling key aspects of the system: outdoor air temperature, supply return, etc. I would say less important if you have a whole lot of zone thermostats, for example. That might be less important than checking the very critical sensors if you have a time constraint and a lot of area to cover. And we also have tools available to check out in order to accomplish this calibration. We have CO2 calibration tools, as well as temperature, etc. Now, another important part of the process is functional testing. So testing all of the modes of operation, including occupied, unoccupied, during warm-up. What is that equipment doing? Is it doing what it is supposed to according to the prescribed sequence of operations? And the method of testing this is going to depend on each system, so you'll want to consult the controls operation manual or the building operator for how to engage each mode of operation. But just making sure, for example, are your dampers staying closed during warm-up, or are you getting the results that you expect when you engage these modes? So another thing to look for are instances of simultaneous heating and cooling. And so you can review your sequences for what is intended. This image here shows an infrared camera image. So the warmer colors indicate hotter temperatures, and the blue cooler colors indicate cold temperatures. In this case, this is a VAV system serving a large open area. This may actually be designed for simultaneous heating and cooling, but there are many instances where that is not desired, and so it's important to understand what the design is and look for those unintended instances. So I saw recently in a hotel lobby, they had two heat pumps that were constantly fighting each other because anyone had access to those controls. And you had one over near the little coffee stand, and you had another over near the window. So guests would be cold over here and want to turn up the air conditioning, and then over there they would be turning it down. So that was very simply solved by putting both units on one thermostat. But this unintended simultaneous heating and cooling can be a real drain on energy. Next, what we want to look for is air balance issues. And some common symptoms of air balance issues are negative building pressure, a draft at the front door, or the door being very difficult to open, for example. You may have condensation leaking from grills or hot and cold spots. Your building operators may be consistently getting hot or cold calls. You may see, if there's a commercial kitchen, you may see smoke loss at the hood, or high velocity at the pass-through. So any of these symptoms that you observe should be followed up you can contract with the facilities manager can contract with a HVAC tab or test, adjust, and balance professional. And some of the tools that they would use would be a manometer to get static pressure readings. and a flow hood, which will measure the output of conditioned air, for example. And we also have these tools available at the tool lending library.
Melissa,
Yes.
if I may interrupt a second, can you speak
Sure.
a little closer to the microphone? It feels like the sound has gotten slightly fuzzier, so I'm trying to.
Oh, okay. Yeah. Is that a little bit better?
Definitely better. Thank you.
Okay, great. Okay, so let's move on here. We want to also identify zones that may be dominating the multiple zone system. So, for example, you may have a server room served by a central HVAC system that kind of clogs and keeps that system on more often than it needs to be for the rest of the building. We have potentially like a 24/7 dispatch center here, picture on the left. So a solution for this situation might be to install, for example, a mini split system in one of these zones to serve that zone so that the rest of the equipment can serve the lighter loads required by the rest of the building more efficiently. And then down to the very basics. And this is basic, but often overlooked. And we all know probably how constrained facilities budgets can get and how limited technicians' time can be. So sometimes these are things that get overlooked, but they're extremely important. So looking for dirty filters, that's a big one and a very easy fix. Dirty ducting, grills, coils, missing or damaged panels, damaged mechanical items, and let's see, I think I need to, there we go, there are pictures here. So jammed dampers, disconnected dampers, where the actuator has actually become disconnected. For wiring, you may find on rooftop equipment damage due to animals and birds, for example. I've seen a lot of instances where birds will actually steal insulation from pipes to, I assume, take to use for building nests. And it's very nice of us to provide that material for them, but can cause inefficiencies in our system. So you also want to make note of equipment that may be at or near the end of its service life, so you can recommend more efficient equipment in its place. Okay, and then, also looking for things like if you see a bunch of screws lying on the roof, or maybe insulation that has been removed and not put back. Sometimes maintenance will occur and doesn't quite get finished, and these are things that can indicate issues. All right, let's move on to lighting then. Lighting is often a low-hanging fruit in terms of energy conservation. So you want to, again, carry your light meter with you and spot check the lighting levels by the use type throughout the building. This chart here gives some recommendations for light levels in various types of spaces. And so what you're looking for are areas that may be overlit or underlit. Underlit, of course, is a safety concern and productivity concern, and spaces being overlit are an energy concern. Controls. Observe the lighting controls. What is controlling the lighting? Is it a time clock? Is it a mechanical time clock? Is it a programmable digital time clock? Are there occupancy sensors? Are there photo sensors overriding the occupancy sensors based on daylight? So observing these controls and making any corrections or recommendations as needed. Also looking at placement of sensors. Is there an occupancy sensor that is placed such that somebody outside the room walking by can trigger the sensor? so that the lights come on unneeded. Things like that are good recommendations to make for changes. And then more on lighting controls, verifying that occupancy sensors are working. You can do this again with a data logger available from, you guessed it, the Tool Lending Library at the Smart Building Center. And these are also pretty inexpensive little tools, very easy to use. I have the Hobo data logger pictured here, and it will identify areas that are where maybe the occupancy sensor is not functioning, or you can even get a sense of, oh, maybe there are times where the lights are coming on when they shouldn't be, and why is that? So you can see the graph here. The occupancy is shown in blue and the light is shown in black, and there's a good correlation here with the actual need for lighting and the lights actually engaging. So if you were to see irregular patterns here that don't match up, then you might look into correcting that issue. Then again, schedules and making sure that those schedules match occupancy as appropriate. And then identifying inefficient lighting equipment. Of course, LED has made huge strides in terms of quality and reduction in cost, where it's almost, it's pretty much at this point a no-brainer to replace other types of lighting with LED. There are a lot of options available, LED replacement tubes, either utilizing existing ballasts or replacing those ballasts. And so these are really, really low-hanging fruit to look at in terms of identifying energy waste. So I'm going to move on from lighting and talk about domestic hot water. And so let's just touch briefly on hot water, so supply temperatures, adjusting a set point for occupancy and use. And it's a bit of a balancing act, meeting codes and preventing any potential health issues, but not heating the water more than you need it. You also want to look at your circulation pump controls and make sure those are functioning correctly. Insulation is an important one with any kind of conditioned water, either hot water or chiller water. And I mentioned before, sometimes rooftop insulation can get damaged by animals, and it's important to observe that and keep it intact and keep it in good condition. That's a really easy way to conserve energy, is to keep that insulation in place. And next, I want to talk about water usage. So irrigation systems are, of course, a huge one, for huge potential for waste. You want to, first off, identify if there's a rain sensor. Some of them are, some irrigation systems have a sensor that will automatically override the programming in case it is raining. Some are a more manual process where you have to say, oh, it's going to rain today, I'm going to override my schedule. It's important to test these and calibrate them and replace as necessary. And water usage and cooling towers, of course, is another big concern for reducing the wasting of water. Water is energy too. I want to remind everyone of that. We often think of energy as just being electrical use, but water is a valuable resource and also requires a lot of energy to move it and treat it. About a third of the world's electricity goes to moving and treating water. So it's an important topic to keep in mind that water is energy too. So with your cooling towers, you want to verify that your conductivity meter that controls blowdown is calibrated and functioning properly. If you're noticing a lot of water loss, then there's potentially an issue. Water features, of course, reviewing the schedules does that. Water fountain or water feature need to be on all night, for example. And then maintenance and repair. You want to check for leaks, broken nozzles, etc. in your irrigation system. Overspray is a typical and pretty common problem as well. And looking at schedules, does it really need to be on as long as you have it set to be? Now, inside the building, checking all of the fixtures for flow rates and recommending low flow fixtures or aerator replacement. And you can get these, many of you may be familiar with these bags pictured here. You can get these often from your local water utility. And this will very easily allow you to measure the flow in the various water fixtures. You also want to double check and make sure that sensor activated fixtures are operating properly and turning off correctly as well. Okay, so let's move on to the building envelope. So as you're walking through, observing elements of the building envelope, you're checking for penetrations that allow for the entry of air or water. You're checking for missing weather stripping. You can see that pictured here in the photo of, at the top. Elevator shaft dampers, making sure that those aren't stuck open. And insulation, again, making sure that there isn't damage to insulation. Areas where the insulation may have been pulled back to do a repair in a pipe, for example, replacing that insulation could be a recommendation. And any significant duct leakage, so disconnected ducting or holes. And our infrared camera can be a really good indicator as well. Another really good tool to carry with you on your walkthrough is a piece of paper, or even better, a piece of toilet paper or tissue. And you can just hold that near your door jambs, and if there's air movement, the paper will flutter. Pretty easy tool to carry around. Another tool is a smoke pencil. It's a very inexpensive tool. We also have one available in the lending library. And here's an example of the infrared camera application. So the infrared camera, again, the red or warmer colors indicate warmer temperatures. The blue areas indicate the colder temperatures or where exfiltration is happening. You can identify thermal bridging or areas where that readily conduct heat to the outside of the building. You can identify missing insulation, air leaks, moisture trapped in insulation. That's really useful. And you can detect construction failures. So, or where you may see some insulation that has started to pack down and you have gaps at the top, for example. So the IR camera is an invaluable tool, like I mentioned, for all sorts of applications that I won't get into here. So that's what I have for this presentation. Just in review, building retuning is a systematic process, identifying no and low cost problems or corrections to operational problems that lead to energy waste. And our major focus areas are HVAC, lighting, domestic hot water, water usage, and building envelope. And building retuning is an observation and a data-driven process. So I'd like to go ahead and open it up for questions. And thank you so much all for your time.
Thank you so much, Melissa. Great information. We have one question now, and everyone, please write your questions in for Melissa about the information she's given, or you can ask questions about her tool lending library and about the building operator certification as well. So the question that we have, so start typing, and I'll read them out to Melissa. The question we have now is, actually we have a couple of questions. So talking about, this person thinks maybe a little out of scope, but we're talking about adjusting startup sequences in buildings to avoid large demand charges. Will this save energy? Most likely it will save on their utility bills, where we pay sometimes 50% on demand. So I'm not sure.
Yeah.
Yeah.
So what, I'm sorry, if I missed the question, I guess.
Yeah.
I agree that
I think I missed the question too. Yeah. So it says maybe outside scope, but so I think will adjusting startup sequences save energy? I think is the question. In demand charges, or will it save demand charges and decrease energy use?
Well, I would say the answer is yes, and it depends. So certainly adjusting startup procedures can save energy. You know, the idea of optimal start is where the, usually in conjunction with a building automation system, is where the system will learn how and when it actually needs to start up in order to get to the conditions at the proper time. And so I think this can definitely be done on a manual process as well, as the operators are paying attention to what actually needs to happen in order to get the building ready for its occupants at the appropriate time. And I think that can be looked at in terms of saving energy. And it really depends on the other processes going on in terms of saving on your demand charges as well. It really just depends, but I would say certainly looking at, do you have other large process loads going on while that equipment is starting up? And how can you potentially stagger that so that it's not all happening at the same time?
Okay, here's
Hopefully
a follow-up.
That answers the question.
Yeah, and here's a follow-up question, sort of. So I'm going to read this to you. If, according to a building operator, the facility is unable to reach required set point, for instance, Monday mornings, is it better to lengthen the optimum start maximum time, for example, from 2 hours to 4 hours, or increase the occupied start time, for example, 6 a.m. instead of 8 a.m., if occupants come in at 8, or something else? Does that make sense? I can read that again if you need.
Yeah, please read it again.
Okay. So what if the building operator says, I can't reach what we need to reach, the required set point on a Monday morning when people come in. So what should I do? Should I increase the maximum start time from 2 hours to 4 hours, or increase the occupied start time, so start it at 6 instead of at 8 when occupants come at 8, or something else?
Yeah, it's going to depend. It's going to really depend on the building itself, but I would say probably either of those is going to yield the same outcome. What I would do is try incrementally, maybe increasing the start time, or say, instead of saying that you are going to start 2 hours earlier, start maybe an hour earlier, try that incrementally and see how that goes. Now, the other way you could do that is by logging the power on your system. We do have power logging meters available here at the Smart Building Center. It really give you an exact picture of which option is going to be more effective. It sounds to me like either way you're you're increasing the amount of time needed for startup, if that makes sense.
Yeah, and someone else chimed in their opinion, saying optimum start instead of the instead of the length, I think. Optimum start hopefully minimize the OSA, so optimum start is better than occupied mode.
Mm-hmm.
So then I have another question.
Sense, but go ahead.
So it sounds like it depends.
It depends, but I appreciate that comment because, you know, I'm certainly not the only expert in the room, and we have a lot of very experienced people, I'm sure, attending this webinar, so I appreciate that input as well.
So sensor calibration, is there a publicly available schedule based on system sensor servers or serves? I'm not sure. So Perry, if you can explain that a little better. Do you understand that?
Is there a publicly, I think that's going to be dependent on the specific equipment, if I'm understanding the question correctly. So consulting the manufacturer on that, but I guess, you know, it really depends on the equipment. Are you talking about CO2 sensors? Are you talking about temperature sensors?
I'll let him clarify that. Meanwhile, about the envelope, do you have anything to say about auto opening doors, such as for handicap auto opening doors, the time delay after, it says time delay after sensor, but I think it's basically about time delay, and it sounds like, would that have anything to do with energy efficiency?
Yeah, like absolutely. That's a great question, and I think as much as you can play with that time delay, that's, of course, again, going to be a really tricky balance between allowing enough time for that to function properly and not keeping things open so long. These kinds of automatic building openers are, you know, in my observation, often an issue. I mean, I all the time observe areas. I know there was a grocery store that I shop at regularly, and they did a big upgrade, and they installed a new stairwell next to the entrance. And so people coming down the stairs from the parking garage, every time it's close enough to the landing of the stairs is close enough to the sensor for the doors that every time someone comes down the stairs, the front door opens as well. So it's definitely tricky to get those controls working properly. In terms of a solution for that, I'm sorry, I don't really have a good solution for that other than playing around with trying to find that balance and minimizing the open time as much as possible.
Okay. Any more questions? I have, I think that is it. Oh, there.
I would say on that last one, an air curtain can serve the purpose of helping to reduce the energy used in an automatic door opening situation. Great,
thanks. So the sensor calibration question was about a schedule by system type, such as HVAC or lighting. So by the system type and not manufacturer specific.
Mm-hmm. Yeah. So, and depending on the device, I mean, ultimately what you're looking for is that device reading what it says it should read. So just checking it with an alternate device that is, you know, tuned and accurate. For example, we have CO2 meters here that are a little more expensive than the typical cheapies, and so that's going to be a higher quality calibration to just test and make sure that what your sensor is outputting is within the desired range or within the correct range.
Okay, great. I have another question, but people are leaving and going back to their going back to, I was going to say going back to their desk, they're probably still at their desk. And I just want to let you all know that we would appreciate you taking the quick survey that you will get when you close out. We'd appreciate it very much. Meanwhile, another question about the tool lending library. Do you have the ability to look up by the system and not by the tool? So I guess, you know, all the tools by lighting and for lighting, all the tools by HVAC, et cetera.
Yeah, so we are, I appreciate that comment because I am in the process of trying to improve that website in order to provide that kind of navigability. So we do have some resources available that show, I'm just going to it right now so I have it in front of me so I can be more accurate about what I'm telling you here. But it's typically just set up based on the type of tool, not necessarily the application. I am always available for consultation on that note, so feel free to just send me an email or give me a phone call, and with your particular application, I will be glad to point you to the correct tool.
Excellent. So if there are no more questions, I want to thank Melissa very much for your presentation and everyone for attending on this July Day. And you know how to get in touch with Melissa and me if you have questions. Please let me know with the survey what other topics you might be interested in learning. And thanks for the presentation. And have a great day. Thank you, Melissa.
Thank you, Karen, and thanks everybody for joining us. I appreciate the opportunity.
Okay.
Talk to you all soon.
Bye-bye, everyone.
Bye-bye.